When compositing an image over the background, we need the alpha channel that determines which pixels of our image should replace the background. Alpha channel is the map of transparency, or I should rather say the map of opacity. Alpha of 1 means that the pixel is opaque. Alpha of 0 is fully transparent pixel. And everything in between are semi-transparent pixels. So far so good, nothing new. And say we want to create beautiful picture of our default cube placed on this wonderful background. We have to render this and use one of the ways of compositing the image over the other image, like for example color mix node, and simply take the background, plug it to the upper socket, then our render to the lower one, take a look at it, and we see that it fully covered the image. So we have to use the alpha channel of this image. One way would be to take the alpha channel from here and plug it to the factor. The other way would be to turn this jackbox on. This says that the alpha of the lower image will be taken into account, so it gave us the same result. And there is also another way. Instead of using the mix node, we can use the color alpha over node. And now we take the background, plug it to the upper socket, then the foreground, plug it to the lower one, take a look at it, and that's the result that we have. Something weird has happened, but if we turn this convert pre-multiply checkbox, we have kind of what we want. I purposely say kind of, because none of those ways of compositing our render with the background went correctly. Let's make the issue more obvious by changing the color of the sky. I will change the horizon color to something like this, and let's re-render this, and now take a look at the result here. We see that we have the fringe that has the color of the sky, so maybe we should turn this convert pre-multiplied off. Definitely not what we wanted. So let's see what happens if we use the color mix and take the background, foreground to the lower socket, turn this option on and take a look. So maybe instead of using this option, let's plug the alpha here. Same weird result. So where's the problem? Those results are caused by this little thing. When we take a look at the render settings and open the shading panel, here we see that we have alpha. And this gives us the alpha mode, and we can choose from 3 options: straight alpha, pre-multiplied alpha, and sky alpha. By default, it's set to sky. And I would say that this is the worst choice of all of the 3. I have replaced the cube with the sphere, changed the material to be pure white, shadeless, and re-rendered this. And let's take a look at the result when the alpha mode is set to sky. This is how our render looks like. The color of the background is set to the color of the sky. This image has the alpha channel, but we don't see it here, but we can use one of those 3 options. So here we are looking only at the colors of this image. Here we have the same image composited over the transparency grid, and that's the alpha channel. Let's choose the first option, change the alpha mode to pre-multiplied, re-render, and this is our result. Let's zoom in here. And we see that we have nice smooth edge, black background. This is composited over transparency grid. That's the alpha channel, and it looks exactly the same as the image because the color of the sphere is pure white. Now let's change the alpha mode to straight alpha and re-render. And this definitely doesn't look nice because of this jagged edge. But here is how the alpha channel looks, and here is how this image looks composited over transparency grid. This jagged edge disappeared. So intuitively we wouldn't choose this option, but that's the best option to choose from, and this will all become clear when we understand the relation between RGB channels that described colors and the alpha channel depending on the mode of the alpha that we choose. No matter which alpha mode we choose, there is certain math that is going on when we composite the foreground over the background. We have the foreground color, and we have the alpha of this foreground, and we also have the background color. The math goes like this. We take the foreground that is multiplied by the alpha, and then we add the background, which is first multiplied by inverted alpha, which means 1 minus alpha. And this gives us the result. That's exactly what is going on when we composite the foreground with alpha over the background using the mix node, when this option is turned on. Or if we turn it off and plug the alpha here. This is exactly the same. When we take a look at this image using this option, this means that we are looking at the straight colors. We see that at the edges we have the full color of this object. This is the alpha channel. And as you can see on the edges, it's anti-aliased. And it's alpha that will take care about smoothing the edges. So we don't care that here we have the jagged edge. We could as well have this color extended all over the picture. But when we use the alpha, here, no matter what color we have, it will become black. It will become 0. Because alpha here is 0. So there is nothing wrong with having something like this. This color will be multiplied by alpha. So this pixel, for example, it has the color like this, but alpha like this. The product of those two will be added to the background. But the background will be first pre-multiplied by inverted alpha of the foreground, as we can see here in the equation. So when we take a look at the resulting image, we see something like that. No jagged edge, and the colors are smoothly interpolated between each other. So this is what happens when straight alpha is used. Mix node needs straight alpha. When we change the alpha mode to pre-multiplied, let's re-render this, we see that here the edge is a little bit darker. Let's now take a look at this image. Right now we are looking at the straight colors, and you see that those colors changed because they have been pre-multiplied by the alpha. And this is burned into the RGB. So setting pre-multiplied alpha is like preparing for compositing. Because when we take a look at the equation, we see something like this: foreground times alpha. So this part is taken care of by setting the alpha mode to pre-multiplied. Those colors represent this part of the equation. But mix node doesn't understand pre-multiplied alpha, so we see this weird darkness, but alpha over node understands that there can be pre-multiplied alpha. And we see that we have what we want, because default settings of alpha over node required the colors pre-multiplied with alpha. Let's use the alpha over node, but instead of using pre-multiplied alpha, let's use the straight alpha and see what happens. Now the result is weird, because this node assumes that what goes into the lower socket is the image with the alpha pre-multiplied. But in this case, it's not. So we have to first pre-multiply this image by the alpha, and we can do it here by turning this checkbox on, convert pre-multiplied. So when we use the image with the straight alpha as the second input, we have to turn this checkbox on, convert pre-multiplied. But if we plug already pre-multiplied image here, we have to turn it off. So alpha over node can deal both with straight alpha and pre-multiplied alpha. However, chances are that for any reason you have to use the mix node instead of alpha over node, but you have the image that has pre-multiplied alpha. In this case, you have to unmultiply this, which means divide it by the alpha. You can do it by using another mix node, set the blending mode to divide, and take the image and divide it by the alpha. This way you have the nice result. Let's mute this node, and that's the color that is twice multiplied. And when we activate this node, we have the nice alpha. So this is manual converting the alpha mode from pre-multiplied to straight. But sometimes you don't have such easy access to the alpha channel. We can do this division or unpremultiplication using converter alpha convert. And it's set to key to premultiplied, which means that it assumes that the image with straight alpha goes here, and here we have this image premultiplied by the alpha. But when we change it from this option to premultiplied to key, it's assuming that premultiplied image goes here, and this divides it by the alpha. and we get nice result. So those are the options that we can use when we choose between straight alpha and pre-multiplied alpha. But what can we do with this crazy thing? When we use the sky alpha mode, all of our objects will be composited over the sky. I have set the color of the sphere to something like this, and to make the issues really obvious, this is the color of the sky that I used. And this is our render when we look at the straight colors. Every pixel that has alpha of 0 is filled with the sky, the object has its color, but at the edges, all of semi-transparent pixels are the mixture of the object color and the sky color. We have the alpha channel, and it looks like this. But when we composite this image using this alpha over something else, we are not compositing the original color of the object, but those colors, mixed colors. So this is the image that we get composited over transparency grid, and we see the fringe that has the color of the sky. So when we take this image using this alpha and want to composite it over such color, this is our result. Definitely not what we wanted. Converting the alpha mode won't do any good. Key to pre-multiply, pre-multiply to key, alpha over node also won't do any good, no matter if we use convert pre-multiplied or not. So let's analyze the scenario that happened to me once. I was working on some animation and I had a pretty long render times. 30 seconds of animation, few minutes for each frame, so I used several computers to render this, and it anyway took whole night to render. I used some texture for the sky and wanted to use my renders to composite them over something else. In the morning I noticed one little thing. I forgot to change the alpha mode, and I used the default sky. So I had two choices. One was to re-render everything. Definitely not the option. So I chose the other option, to fix those colors present at the edges of my objects. Let me show you what I did. I created the node group that takes care about this issue. And this is the group in action. I called it Remove Color Matting. It works such that we plug the image into the upper socket, and into the lower socket we plug the color or the image that represents the color matting. In our case, we should plug the sky here. In this case, I used the solid color of the sky, so I can simply copy this and paste it here. But in my original case, I had the texture that I used for the sky, I had some camera motion and so on. So there was something that I had to re-render, but I didn't have to re-render all of my scene. I rendered only the sky, which took like minutes on one computer instead of whole night on 6 computers. Then I took this render of the sky and plugged it to this lower socket of the group. In our simple scenario, I simply copied the color of the sky to this lower socket. Let me plug it here and see what happens. And you see that it fixed the problem. Not 100%, because here we see some weird pixels, but it has something to do with anti-aliasing, and I think that in fact it's a bug. But that's the result that I can work with. So let's take a look at this group. Seems a little bit complicated, but let me anyway try to explain how it works. What I did here is nothing more than solving this equation. The image that I get is the result, right? I also have the alpha channel. What is the background? Background is my sky. So I also have this part. So I have alpha, I have the background, which is my sky, I have alpha, and I have the result. What I am looking for is the foreground. So let's solve this equation. If this is true, I can say that foreground times alpha is equal result minus this. So now when I divide everything by alpha, I will get this. Foreground is equal this divided by alpha. So that's the result that I am looking for, and the only thing that I did here in those nodes was recreating this equation. So first I have the image that goes here as the first input of the group. I need the alpha of this image, so I separated RGBA. and here is my alpha. So first, let's take care about this part, 1 minus alpha. Here I take the mix node with a subtract blending mode. As the upper input, I placed the white color, which is the equivalent of 1, and I subtract alpha from it. Now I have to multiply this by the background. Background comes as the second input of this group. And here I am multiplying this, 1 minus alpha, by the background. That goes from here. Now I have to subtract this from the result. And this is taken care of by this node. So I take the result and subtract this from the result. Subtract blending mode. And all this has to be divided by alpha. So I have the mix node with divide blending mode. Take this and simply divide it by the alpha. And this is my result. So as you can see, a little bit of math can be helpful in solving some issues, and we can perform some simple or sometimes even more complicated math operations using the nodes. And when we know what we are doing, the results may be amazing. This episode was rather technical, but this knowledge will be very helpful in understanding next episodes.